Okay, number 15. First thing we're going to establish is, do we have pressures or concentrations, or maybe even said, do we have the ability to get pressure or get concentrations? And I see moles and liters, so that tells me I have the ability to get concentration. So I got to figure out the concentration for anything that I'm given. As I read this, it tells me during an experiment, 3 moles of each component are present at 1.5 liters. So that each would be all of these. Each has to be all. So for each, we know the concentration is going to be 3.00 moles over 1.500 liters. So we get 2.00 for my concentration for all of them. So that is the initial concentration. So I know I need an ice chart. So I'm going to say H2 plus F2 going to 2HF. I know I have 2.00 here, 2.00 here, and 2.00 moles here. Remember, our ice is initial change equilibrium. So I don't have a direction, and I need to have directions to get to my E, so I have to do a Q versus K. My Q versus my K. All right, that means we have to be given K. We are given K to be 1.15 times 10 to the negative second. To get Q, I set it up just like I would a K, meaning that I would have HF squared over the over F2. Let's do H2 times F2 based on my balanced equation. So therefore, I'm going to put 2.00 squared over 2.00 times 2.00, and you can see this all becomes 1.00. If you need to crank that into your calculator to numerically see that, please do that. So then I can put this back up here as 1.00, and then I know that this is going to be this direction. Okay, so because 1 is much greater than 1.15 to the negative second, so I know that Pac-Man is going to start out here at my arrow, and Pac-Man starts here at the arrow like its starting point for the Pac-Man game, and it has to eat positives. So Pac-Man is facing the left. That means my positives have to be on the left. So this is going to be plus x and plus x. This side is minus 2x. Okay, so let's talk about why it's plus and minus again. We know Pac-Man is facing this direction. Okay, Pac-Man is facing this direction. So if Pac-Man starts here at my arrow, it has to go to the left to travel, because that's the direction it's facing, and it can only travel if it has positives to eat. So these are the positives. This side is the negative by default. Why is there no numbers in front of this x? Because there's a 1 here, so there really is a 1 there. There's no number in front of this x because there's 1. Why is this 2? Because there's a 2 in front. So my E becomes 2.00 plus x and 2.00 plus x and 2.00 minus 2x. Now remember, we were asked to figure out the equilibrium concentrations of all the species. So here we have that. To get that, we need to do a K expression. K is just like Q, except K is at equilibrium. So we're going to do HF squared over H2 times F2. When we do that, we're going to get HF is going to be 2.00 minus 2x, and we're going to square that quantity. Below, we're going to have 2.00 plus x times 2.00 plus x. So hopefully what you've noticed is that I didn't put this in here before, but we already know the value of K here from the word problem. This was 1.15 times 10 to the negative second. So 1.15 times 10 to the negative second equals 2.00 minus 2x squared over 2.00 minus x time, and those two are going to actually better said than that. Let me do some erasing here. If you notice, the bottom thing is a squared fact also, because this times itself, oops, that was a plus x. Please correct that if you're following along with me. This was a minus 2x, and this times itself is squared, so that means I can square root both sides to solve for x. When I take on my calculator and I take the square root of 1.5 to the negative second, I get this to be 1.07 times 10 to the negative first. This side would be 2.00 minus 2x. And this bottom part would be plus x. So if I take the square root of square, remember it's the same thing. We're going to continue to solve for x. To do that, we have to put this over 1 and cross multiply. So then technically this is going to be 1.07 times 10 to the negative first times 2.00 plus x equals 2.00 minus 2x. I'm going to distribute this through. So 1.07 to the 1 negative times 2. That's going to give me 2.14 times 10 to the negative first plus 1.07 times 10 to the negative second, negative first x. I just distributed that through, multiplied it through the whole thing. Let me make that x a little clearer. That's still equal to this side. Nothing needs to be done on that side because it's times 1. Now I'm going to combine like terms. So I'm going to add a 2x to both sides. And again, like I said on other problems, you don't necessarily need to do all this. You could show just the pieces that you want on your paper. The more you show, though, like I said before, the more I can help you. So now this is 2.14 times 10 to the negative first plus 2.1, technically 1 if we're doing sig figs, x equals 2.00. So now I'm going to get this on the other side to continue to get like terms together. And so I have 2.11x equals 2 minus, sorry, my dog's having issues over there, 1 negative. I get on this side 1.79, rounding with 2 sig figs. So then I can divide both sides by x. And so I get 1.79 divided by 2.11. And I get my x to be 0.848. So that's only x. This is a 0. Make sure that's clear and doesn't look like a 6. Now, there you go. There you go. Okay, so that's x, but we're not done. We just solved for x. We want to know the concentration. So now we got to plug x back up in here. And I'm going to switch colors for that, just so it's easier to see. So for both of these two, let me make my pen a little thinner so you can actually understand my writing. It's going to be 2.00 plus, I already forgot what our x was, 0.848. Okay, and this is going to be 2.00 minus 2 times 0.848. So I'm just going to go down here to show my work. So for H2 concentration and F2's concentration, it's going to be 2.848. And for HF's concentration, it's going to be 2 minus 2 times 0.848. And I get a concentration of 0.304, and that ends this problem.